All right, to add and subtract scientific notation, our objective is to add, subtract, find the sum, the answer, the difference, the answer, to two or more numbers written in scientific notation. So what we're going to do today is a combination of what we've been working on. We're going to first expand the number, meaning make it bigger, right? We're going to put it in standard form. Instead of it being in scientific notation, we're going to take it and change it to standard form, standard notation. After you expand the number, you rewrite it. You're going to add the numbers together. Get a calculator, add them together. Or do it mentally. And step number 3 is to rewrite the answer in scientific notation. Rewrite the answer in scientific notation. 3 easy steps. Expand the number, make it big. Rewrite it. Then you add the 2 numbers together, or the 3 numbers together. And then you take your answer and you write it back into scientific notation. Here's an example. 3.4 times 10 to the third plus 2.15 times 10 to the fifth. All right, so step number 1 says expand the number. Who can tell me 3.14 times 10 to the third? How do you expand that? What would we do? Move the decimal how many times? 3 times. And is it going to get bigger, so I move this way, or is it a smaller number, so I move to the left? Bigger. So I'm going to move my decimal 3 times. 1, 2, 3. Is that my answer? You have to add, fill in zeros. All right, so it's 3,400 plus. Who can tell me how to do this one? Safi? So I write the decimal, 2.15, 2 and 15 hundredths. And how many times do I move my decimal, Safi? 5 times I move my decimal. Is it going to get bigger or is it going to get smaller? Bigger. 1, 2, 3, 4, 5. And fill in the zeros. So I'm done with step number 1. Step number 1 was expand the number. Put it in standard form. Done. What's step number 2? How come I'm adding in this problem? Because it's an addition problem. You can use your calculator or you can start at the decimals. 0 plus 0 is 0 plus 0 is 0 plus 4. 5 plus 3. 1 plus nothing. And 2 plus nothing. So here's my answer. 218,400. 218,400. Is that my answer? Am I done?
No.
No. Step 3. Rewrite the answer in scientific notation. To take a standard number and put it into scientific notation, step 1 said find the decimal. Looking at my answer, where's the decimal? At the end. I found the decimal. Step 2 said move the decimal so there is one non-zero digit to the left. How many digits are to the left? 6. How many of them are not zero? Non-zero. 4. So I want one non-zero digit to the left. So tell me when to stop. Right here? How about here? How about here? Here? Here. Yes. One non-zero digit to the left. 2. 2 is my non-zero digit. So my answer, after you move one non-zero digit to the left, write the new decimal. What's the new decimal? 2.184 times 10 to the 5th power. Is that a positive 5 because it's a big number, or a negative 5 because it's a little number? Positive. It's a big number. 218,400. 218,400. All right, let's try another one. (7.3) times 10 to the negative 5th. Andrew, please pay attention. Minus 4.3 times 10 to the negative 6th. Step number 1, expand the number. Put it in standard form. Who can tell me 7.3 times 10 to the negative 5th? Who can do that one? Tommy? Because it's a negative exponent, it's going to be a small number. So I'm going to start my 7.3 over here. And I move it 5 times to the left. 1, 2, 3, 4, 5. Fill in my zeros. Minus. Tyson, can you do the next one? Good. Again, this is to the left because it's a negative exponent. It gets a small number. 6 times. 1, 2, 3, 4, 5, 6. Expand the number. Write it in standard form. Step number 2 says add. What? What do I do instead? Yeah, so let's change that rule. Add or subtract. How do you know when to add? It has a plus sign. How do you know when you subtract? It has a minus sign. Tricky, right? I would use a calculator for this one. I mean, we could not use a calculator, but why not? Triana, what'd you get? Yep. So 0.0 How many zeros? After the decimal, how many zeros? 4 zeros, then what? 6 what? 8, 7. Do you guys agree? Right? And this is the purpose of scientific notation. This was difficult for us to get right, for you to tell me what it looked like, right? You can't read it correctly. It takes too long. It's hard to say 0.0000687 and have somebody follow along immediately. So that's the purpose of scientific notation. So is this my final answer? No, I want one non-zero digit to the left. So I have to move this time to the right to get there. So tell me when to stop. How about here? Here? How about here? How about here? How about here? Yes. One non-zero digit to the left, which is 6. So I'm going to write 6.87, 6 and 87 hundredths, times 10. And I moved 1, 2, 3, 4, 5 times. Am I going to write 5? Why is this one -5? Because it's a small number. This one was positive because it's a big number. Adding is pretty easy. Subtracting is pretty easy. Expand the number, write it in standard form. Then you either add or subtract. You do what the problem tells you. And then you rewrite the answer in scientific notation.